So let's start. Lesson 6. We'll do the first half today. We'll finish it off tomorrow. And Justin, it says this. The title is Using Permutations and Combinations to Calculate Probabilities. And what I wrote here is, for experiments with only a few draws from a deck of cards, like maybe 2 cards, or from a pot where there's bills to pick, a 20, a 10, and a 5, maybe picking twice, it's usually easiest to use a probability tree diagram approach and then multiply down, add across. But as soon as you're drawing multiple cards, anything more than 3, and even 3 sometimes is my limit, or as soon as you're picking more than 3 marbles or picking more than, you know what? The tree method becomes very unwieldy, and we need to use permutations and combinations. So I'm going to start out with one that I would do a tree for, a 2-draw experiment, but we'll see if we can generate a combinatorics approach for picking 2 cards, and then see if we can generalize that for picking 5 cards or 10 cards or however many cards you want to pick. Got the approach? Let's start. Suppose 2 cards are drawn without replacement. That's probably important. That means the odds are going to change along the branches. From a shuffled deck of 52 cards. So we got my deck of cards here. It wants us to calculate the probability, Cole, of what? Calculate the probability that they what? Read to me, Cole, my friend. Sorry, louder? That they're both aces. You know what? That depends. Depends on the second card being an ace, depends on whether what? First card is an ace. I think my tree is going to be ace on the first, ace on the second, and I would use a tree because I'm only picking 2 cards. I would say, hey, how many aces? In fact, I set the tree up here. Ace, not ace, ace, not ace, ace, not ace. How many aces are there in the deck? 4 out of? Okay, so if I was labeling the branches, I would label this as 4 out of 52, 48 out of 52. And then down the left branch, we picked an ace. How many aces are left? 3 out of 51. How many not aces? 48 out of 51. Down the right branch, we didn't get an ace. I guess there's 4 out of 51 and 47 out of 51. Cole, what did you say this question wants us to calculate? The probability of what? Hey, which branch or branches is that? Is it more than 1 branch? No, just 1? Which branch? Cole? What times what? Okay, so in terms of probability notation, the probability of ace on the first and ace on the second, if I wanted to write, and I won't be fussy if you don't bother writing that, but I'm worried that the textbook or the homework may use that notation, so I'm trying to show it to you as much, and I've already told you I'm not a big fan of the notation. I like the tree better. Oh, the only time I go to the formula and the notation was for the last lesson on conditional, because that's how I wrap my brain around it. It's going to be multiplied down. 4 out of 52 and 3 out of 51. I think it's going to be top times top 12. 52 times 51 is 26, 52. Okay. By the way, the other way to write this in terms of a formula, the probability of ace 1 and ace 2 is the probability of ace 1, that's the 4 out of 52, times the probability that the second card is an ace given that the first card is an ace. The probability of ace 2 given ace 1. That's that 3 out of 51. Now that's a given as well. You're not going backwards up the tree. Jacob, what they're saying is, since that's the second card an ace and that's the second card an ace, make sure you use the 3 out of 51, not the 4 out of 51. Make sure you use the ace 2 down the branch where you picked an ace on the first one. Don't use the other one. What if we wanted to do this using combinations? I said a sample space is the list of all the possible equally likely ways to pick 2 cards from 52 cards. So how many ways can you choose 2 from 52? I think that would be from 52, choose 2. Which is what? Now you need to remember where that is on your calculator, and I'm deliberately not going to remind you. You're going to have to see if you can dredge that from your memory. Yeah, you're right. What is 52 choose 2? 1326? Then I wrote the number of unordered ways to select 2 aces. How many aces are there in the deck? Choose. How many aces do we want to choose? 2. Hey, what's 4 choose 2? The probability that both cards are aces, I wonder if that's from 4 aces, choose 2 of them, divided by from 52 cards, choose 2 of them. I wonder if that's the event that we want, 2 aces, divided by the total number of events, 52 cards, choose 2. Let's see, that would be 1326. No, sorry, that would be 6 over 1326. Can you enter that into your fraction button and tell me what that is in lowest terms? One out of 221. Hey, and while we're at it, up here, because we know the answer is 12 out of 2652, can you reduce this one up here into lowest terms, please? And let's see, I hope, do we get the same answer using a choose method and using a tree method? You also get 1 out of 221. So I'm going to say, it looks like, Justin, another way would be to say, how many different ways can the event that we want occur? Using choose. Divided by how many different ways can any of the type of event occur? The total number of successes, number of ways to get 2 aces, divided by the total number of outcomes, the number of ways to get 2 cards. Oh, and cards are chooses, generally. Well, believe it or not, you could have done this with permutations. Now, we will rarely use permutations to do probability. And Ellen, when we do, it'll be really obvious because they'll be talking about a given an order. But for what it's worth, I think if you go 52p to, what do you get? $26.52. And if you go from 4 aces P, permutate 2, what do you get? Yeah, they're watching a video next door. Chill out, relax. I'm sure it's a good physics video. What do you get? 12? And so another way of doing this is 12 out of 26.52, which is actually the original fraction that we got before we reduced it to lowest terms, right? We got 3 times 4, 12, which is 1 out of 221. As I said, I kind of stay away from using permutations. I tend to use combinations, especially for card questions. Did I say card questions? Turn the page. Christina, joy of my heart, can you read to me, please, example 1? How many cards? Do you think they want me to do a 5-level tree that would have, I think, 32 branches at the bottom? Do you think they want me to do a 5-level tree? Everybody say no. Do you think they want me to do a 5-level tree? This is how you know that they probably want you to use a combination approach. 2 cards? Yeah, tree. 3 cards? maybe a tree, maybe not. Anything more than that? No. So, keep reading again. Okay, so we're not replacing them. Yep, keep going.
Determine the probability of each of the following events.
What's event A?
The 5 cards are all spades.
How many cards?
5.
This is a job for a bucket. Remember the bucket? So we're going to go like this. And it looks like we have spades and not spades. How many spades are in the deck? 13. So how many non-spades are in the deck? Use the complement. How many? 39? It's a nice review coming back to us. Hey, how many spades do they want us to pick, Christina, for this particular question for part A?
5.
How many non-spades do they want me to pick? It's a trick question. Sure, anyone. How many non-spades do they want me to pick then? It's a trick question. None. As a number, please. 0. Okay. Now, if I wanted to know how many different ways that I can do that, it would be 13, choose 5, and 39, choose 0. Now, that's not a probability. That's just how many different ways. To calculate the actual probability, it's going to be divide by the total number of ways that I can choose 5 cards. How can I figure that out? How many cards are in the deck grand total? 52. Choose. How many do I want to pick? Which is what? And this will probably give it to you as a decimal. So with the choose method, we often will not get answers as fractions. But can you go 13 choose 5 times 39 choose 0? Although, what is 39 choose 0? 1. So you can probably avoid typing that if you're really lazy. Divided by 52 choose 5. By the way, 5 spades. Is that a good hand or a bad hand? What do we call that? Okay, this is a flush. This is a spade flush. I'm going to expect a fairly small decimal because this is a fairly good hand, so the probability should be fairly small. Yes? What do you get? I'll give you, I know it's 0.0, I know there's at least 2 zeros. 0. Read me the next 3 non-zero digits, please, round it off properly. Read me the next 3 non-zero digits, please, round it off properly.
4, 9.
Okay. Mr. Dueck? Yeah? Why did you bother doing the 39 choose 0? Couldn't we have ignored that? Well, sort of, but I want to show you. You may have noticed in this unit, Erica, I like built-in error checks. So on the tree, there was a built-in error check. You had to add one. If you're doing a choose, you may notice that this number and this number add to that number. And you may notice that this number and this number add to that number. There's your built-in error check. So I will almost always write the choose 0 just so I have that symmetrical pattern to double check to make sure I haven't missed anything, although I may not type a choose 0. Oh, and it may not be a choose 0, much like B. Jordan, when you're done yawning, can you read B to me, please?
There are 3 spades and 2 cards.
This is going to be a bucket. You know why? How many cards are we choosing?
5.
This bucket's going to have 3 compartments. Wait a minute, I thought just 2. No, 3 compartments. It's going to be spades, hearts, and others. Hey, how many spades in the deck? 13. How many hearts in the deck? How many others in the deck? How many hearts do I, how many spades do I want to choose? 3. How many hearts do I want to choose? 2. How many others do I want to choose? None? This is going to be over from 52 cards. You're choosing 5 of them. If I was choosing 7 cards, it'd be from 52 cards, choosing 7 of them. What's the top going to be? How can I write that I want to choose 3 hearts? 3 spades. What choose what? It's going to be 13, choose 3, and 13, choose 2, and from 26, choose none. Double check. If I add up the first number of everything, does that add to 52? I don't think I missed anything. If I add up the last number of everything, does that add to 5? I don't think I missed anything. By the way, 3 spades and 2 hearts. Good hand? Terrible hand. I'm guessing this is going to be a way bigger decimal. I hope. Oh, someone coming late. Can you crunch the numbers, please? What do you get? Give it to me to, if you're in physics or chemistry, 3 sig figs. So I think there's a couple of zeros and then 3 digits. 2 zeros? 0, 0, 8, 5, 8. Okay. C. There are 3 spades and 2 non-spades. This is almost like B, except B, we said the non-spades specifically had to be 2 hearts. Here, I think our bucket's only going to have 2 containers, 2 sections, spades and non-spades, because non-spades is others. It's going to look like this. Spades and not spades. How many spades are there in the deck? 13. How many others are there? By the way, look up for a second. Mr. Dueck, on the previous question, I only saw spades and hearts. How would I know to do the others? Well, let's suppose that you didn't write that one there. What's 13 plus 13? How many cards are there in the deck? Grand total. 52. How many do you have in your bucket if you'd forgotten to write that last column? 26. You're missing some. There's also your built-in error check. You better make sure your bucket contains the whole deck of cards. So if your bucket doesn't contain a whole deck of cards, probably there's another column, another container that you need to add. Do we contain a whole deck of cards here? Yes, I don't need to have an others column here. Back row Jake, how many spades do I want to pick?
3.
That can be like your gang nickname. Back row Jake? No? Okay. And how many non-spades do I want to pick?
2.
Hey, what's the top of my fraction going to be?
13, choose 3.
And?
Times 39, choose 2.
Okay. And last unit, we stopped there. Last unit, we said, hey, that's how many different ways you can get 3 spades and 2 non-spades. But now we want to say, I want to change that into a probability. To change it into probability, I divide by the total number of ways, which is what? Choose what?
52, choose 5.
Yep. I think this should be even higher than the previous one, because the previous one we said specifically 3 spades and 2 hearts. Now we're saying 3 spades and anything. I suspect you're going to get a bigger decimal than 0.0058. Again, tell me how many zeros and then give me the first 3 non-zero digits. 0, 815. Anybody else? You want to practice being able to type these in? 815. As a percent, that's an 8% chance. If you're playing 5-card poker, about 8% of the time, you'll get 3 spades and junk. That's why it's not a very good hand. D. Only 2 spades. I guess that means 2 spades and 3 non-spades. Oh, we got a few more late humans showing up. So D is 2 spades, 3 non-spades. Very similar to C. Try it on your own. Go. I'll freeze the screen. Draw a bucket. See if we get the same thing. I think your bucket looks very similar to C with some minor tweaks. See if you get that. Gesundheit. Is that okay, Silke? Yeah? Let's do a better poker hand. So I got .274. I got .274, that there. Yes? Okay. A 27% chance of getting only 2 spades. That's a terrible hand because the probability is very high. You have more than a 1 in 4 chance of getting 2 spades in a generic poker hand. Meh. That won't get you anywhere. E. This is a better hand. What would you call it if you had 2 aces and 2 kings and one other card? What kind of a hand is that? Okay, it's 2 pair. 2 high pairs, which is even better. But, okay. What do you think my bucket's going to look like here? What containers are going to be inside my bucket? Ace, king, and other. Let's see if that gives us all 52. So we have a suggestion for ace, king, other. Let's see if that gives us the entire deck. How many aces are there? 4. How many kings are there? Also 4. So how many other cards are there? 44, is that what you said? I thought I heard you say 34. And I go, really? 44. Erica, we got the whole deck. Okay. How many aces? 2. How many kings? 2. How many others? 1. I think it's going to be 4 aces. Choose 2 of them. And 4 kings. Choose 2 of them. And 44 others. Choose 1. All over, from 52 cards grand total, choose 5. And again, if I do my error check, 4 plus 4 plus 44 gives me 52. 2 plus 2 plus 1 gives me 5. I think I've got everything. This should be a fairly low number because I would think that 2 kings and 2 aces is a pretty good hand. I'm expecting a fairly small decimal. 4, choose 2, and 4, choose 2, and 44, choose 1, divided by 52, choose 5. Ooh, I'm getting a number in scientific notation. Are you guys? Okay. So do you get point zeros? Do you get 3 zeros? And then 6095, blah, 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 blah. Hey, which hand is better to win with? A or E? Which hand is better, A or E? How do you know? But this is why does a flush beat 2 pair? Smaller probability for A means it's a better hand. So this is how the rules of poker are developed. So some of you who play, I just know a flush beats 2 pair. Yeah, but this is why. Okay. We'll win Lotto 649 and then we'll stop for the day. But we'll start out looking at a generic raffle. Three prizes are awarded in a raffle. 100 people each hold 1 ticket. Okay? A says, what's the probability that Alice, Ben, and Conchetta, I just wanted to go A, B, C, so I was picking names that began with A, B, and C. Conchetta, I don't know where it came. Anyways, win first, second, and third prizes. Here's the key word. We're going to underline it. Respectively. What does the word respectively mean? It doesn't mean politely. What does the word respectively mean in this sentence? Okay, draw a little arrow pointing to this. When you see the word respectively, it means in that order. In that what? Order. In that what? Order. Permutation. Order matters. Now, you can solve this using a permutation. I'm not going to. Because how many people are there in this question? I think I can do this with a tree. Okay? And I think the tree is going to look like this. Alice wins or doesn't. Ben wins or doesn't. Conchetta wins or doesn't. It's going to be a 3-level tree. Except I'm only going to draw 1 branch because I want all 3 to win. I want a branch that looks like this. Alice wins. Ben wins. Conchetta wins. That's why, because it's all the same event 3 times in a row, I think I can use a tree. If they had said, what's the probability that 2 of them, that Alice wins, Ben doesn't, and Conchetta does, in that order, okay, that's a much, 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 much tougher question. I'd probably have to go to some kind of a permutation approach. But here, since it's win, 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 oh, and Alice wins the first prize. How many tickets are there? How many tickets does Alice own? What's the probability that she wins? Okay, she wins. Woohoo! Now we reach for another ticket. How many tickets are now left in the pot? 99. How many of those tickets does Ben own? Okay, Ben wins. How many tickets are now left? 98. And how many are owned? What's the answer to this question going to be? Now you can go 100 times 99 times 98. Don't write that. If you did, that's fine. But I'm going to show you a different way to write that. If I recall, 100 times 99 times 98 is really from 100 permutate 3 objects. Here's what we're saying. There's a whole bunch of ways that you can mix up all 3 of these, sorry, let me say that again. There's 100 people that bought a ticket. There's a whole bunch of ways that you can mix them up in groups of 3. How many different ways? 100p3. Of those many, many, many different ways, how many have Alice first, Ben second, and Conchetta third? Just 1. That's why there's a 1 on top and a 100p3 on the bottom. And I think we can actually then do this as a fraction. What is 100p3, or what is 100 times 99 times 98? What is 100p3? Nine, 7, 0, Sean? Almost, but not quite 1 in a million, right? So the probability that those three win those prizes in order, not very high. Let's compare that with B, the probability that all three of them win a prize, but we don't care what order they won the prize in. We don't care what order, that's a combination. That's a combination. That's a bucket. What's our bucket going to look like? I think our bucket is going to have winners, losers, non-winners. Sebastian, how many winners are there? How many non-winners are there? Good. Have we got the entire tickets in our bucket? We don't need to do an extra column or anything like, okay, check. How many winners do we want to choose? How many non-winners do we want to choose? What choose what? What choose what? It's going to be 3 choose 3 and 97 choose 0 all over what choose what? Okay. By the way, can you see, I could give you the same question, but I could have said, what's the probability that 2 of them win a prize, but the third one doesn't? Oh, then you'd have still 3 winners, 97 losers, but from the 3 winners, you'd want to choose 2, and you'd have 1 non-winner. Okay, I could deal with that. Or what's the probability only one of them wins a prize? I could do that, as long as they didn't say what order. I don't care. It's a bucket. By the way, I think 3 choose 3 and 97 choose 0 is also 1. So I think I can write this as a fraction also. What's 100 choose 3? No, what's not as a decimal. I just want, because the top works out to 1. 167? 161,700. Okay. This allows us to figure out the odds of winning 649. So in BC 649, they pick 6 numbers from 49. 6 winners, 43 losers. So what's the probability that all 6 of your numbers are drawn? It's going to be a bucket, because the order that they pick them doesn't matter. They'll put them in numerical order when they display them on TV, but if you picked, for example, Caitlin, a 3, a 12, a 20, and a 19, even if the 3 is the last one picked, that's still a winning number. Is that okay? Makes sense? So this is a choose. Even though they print them in order, doesn't matter when your number gets picked. So as a bucket, it's going to look like this. Winners, non-winners. How many winning numbers are there in the pot? 6. How many non-winning numbers are there in the pot? 43. You know what? Let's use that just as kind of our generic bucket, because we're going to do a part B as well. Part A, it says all 6 numbers are drawn. Hey, what choose what? What choose what? From 6 winners, choose all 6, and from 43 losers, choose none. Over what choose what? Do you see how you can use my built-in error check to figure out the bottom?
Over 49 choose,
This one I want as a decimal. Oh, you know what? Actually, no. Let's leave it as a fraction, because I think the top again, 6 choose 6, 43 choose 0. I think that's 1. By the way, that looks like a 0. Sorry, let's try that again. That's a 6. I think this is 1 over. What is 49 choose 6? 1, 3, comma, 9. Keep going, Sean.
8, 3, 8,
Chance of winning, 1 in 14 million. Oh, well, not quite, but close, right? 13.9, let's just round up. Chance of winning is about 1 in 14 million. Sorry, that's not the odds that they quote, because they want you to buy the tickets. So when they say chance of winning, they mean winning any prize, matching 5 numbers out of 6, or 4 numbers out of 6, or 3 numbers out of 6, and that raises the odds, and maybe you'll be a little less stupid and you'll buy it thinking you'll win. They hope. But chance of winning the grand prize, yeah, 1 in 14 million.
Plus, isn't it like if someone else has the same number?
Oh, yeah, that too.
Then you split?
Yep. Yep. Somebody somewhere was trying to come up with a scheme that, like, hey, Mr. Dueck, if the odds of winning a lotto are 1 in a million, couldn't you buy 1 million tickets? No, because that doesn't necessarily guarantee that you'll win. Well, couldn't you buy every single possible number permutation? Yeah, but then someone else might win the prize as well. That's been tried, by the way. There are mafia syndicates and syndicates that have tried to see if they can somehow rig lotteries, and the reason nobody tries it is because mathematically it's a terrible investment. You're almost certain not to get your money back. B. Okay, I think if you match 3 numbers, I think you win $10. So, what is the probability of matching 3 numbers? Let's modify our equation. What choose what choose what, over what choose what. Okay, from 6, choose 3, and from 43 non-winners, choose 3, all over 49, choose 6. I don't think we can leave this one as a fraction. This one do as a decimal because the top doesn't work out to 1 this time. What's the probability that you win $10? What do you get? 7.6 or 7.7? Round it off properly.
7.777.
Or if I can say about 1.8%. You know what? Let's even round that up. 2%. So let's talk about people who somehow think that they can win money on the lottery. That means 2% of the time, you'll win $10. That means on average, you'll have to buy 50 tickets 2% of the time to win $10. What's the ticket cost? $2. So what's 50 tickets cost? On average, you'll spend $100 in order to hopefully win $10. Is that a good investment? No! No! So, I'll give you the same speech that my math teacher gave me in university. I win $14 a week on Lotto 649 because I don't buy a ticket each day. Think about it.